Now that we know how studies are designed, we are going to talk about what's being measured and how to identify it. So we have some key terms. We have explanatory variable, we have response variable, lurking variable, and bias control. Let's look at explanatory variable first. Explanatory variable, the definition would be that the variable being manipulated or categorized to see its effect. So this variable is what we're trying to change to see if something else is affected. The response variable is the variable that we're trying to see if there's some kind of change in it due to the explanatory variable. The response variable definition, the outcome or result that's being measured. So we do something with the explanatory variable to see if something changes in the response variable. Lurking variable, it's an unmeasured variable that can influence both the explanatory and response variables, causing a hidden relationship. This is a fancy way of saying it's a variable that is unexpected, that may have changed your results that you did not expect. And a lot of times when you set up a research study, you're focused on these two variables, the explanatory and the response, and there may be another variable affecting it that you do not realize that's affecting the outcome, and that's the lurking variable. Okay, the fourth definition, bias control. These are techniques like randomization and control groups, blinding, that's used to prevent bias in studies. These are techniques used to reduce unfairness, to make sure that the results are as accurate as possible. All right, let's look at example 5. Why is random assignment important when placing participants into the control and treatment groups? So this is asking, why is it important to randomize the people or things that you put into each of the control groups and the treatment groups? And this question is all about bias control. Random assignment or random sampling, right, that helps us reduce bias by making the groups more similar to each other from the start. So any of the differences that might happen is more likely due to the treatment, which is what we want. We want to see results based on the treatment so that we can get the best and most accurate results. So when we pick whoever goes into each of those control groups or treatment groups, we want to make sure it's randomized because it reduces bias and creates balanced groups. So the answer is choice B for example 5. Example 6, a study finds that students who sit in the front row of class tend to earn higher exam scores. What might be a lurking variable? So we're looking for something in addition to the fact that the student is sitting in the front row that might help the student earn higher exam scores. If we're examining people that are in the front row, a lot of times students who sit in the front row may also be more motivated or pay more attention. And these traits that weren't directly measured in the study. So motivation could be a lurking variable here that was not taken into consideration. So it may be the motivation of the students that sit in the front row rather than the location of the front row that earn them higher exam scores. Example 7. In a study on sleep and test performance, what is the response variable? So there's a study that wants to see if the amount of sleep you get affects the test performance. So the response variable is what we're looking to see if something changes. If we get better sleep, is that going to change the test performance? So the variable that we're looking for here, that's the response variable, would be A, the test scores. Example 8, in a study about caffeine and memory performance, what is the explanatory variable? The explanatory variable is the variable that we change or manipulate to see if we get a response. So what are we changing to see if something else changes, the response variable changes? So if we're doing a study about how caffeine affects memory performance, the thing that we're changing, the variable that we're changing, is the amount of caffeine, and the response variable would be the memory performance. So we're looking to see if the explanatory variable, the caffeine, affects the response variable, which is the memory performance. So in this case, the explanatory variable would be C, the amount of caffeine consumed.